All right, here we go. Example 3. Now we have three linear factors, which when multiplied will create a product. And that product is this polynomial on the right-hand side of the equation, 3x cubed minus 4x squared minus 9x plus 10. You will notice this time I put the linear factors on the left side of the equation and the polynomial, the result, the product, on the right side of the equation. This is still the same problem. I just wanted to kind of present to my audience, you folks, just a different way of thinking about the problem. So if I ever write it this way or that way, you don't feel discomfort. Rather, you feel experienced that you had an opportunity to see it written that way. All right? In case you were wondering. Now let's go ahead and jump into the annotations. So I'm going to go ahead right here. Then I'm going to divide by x minus 1 first. I would divide by x minus 2 second. Next, I'm going to go ahead and put a little cloud here around the leading term. Number 1 is the second term. Number 2 is the second term. I'm going to draw some arrows here because I am going to have to write that the diagonal values from the box, when we combine those like terms, they will have to get these results. Now, I'm going to go ahead and put a square around positive 10 there to remind myself that the last part of my calculation needs to be exactly the same as the constant value, the last term of my polynomial. Let's create the box. One, two, and here I'm going to put x minus 1. Okay. I don't know if I'm going to need this extra box here. I'm just going to put it there. Next, I'm going to put the leading term, 3x to the third power here. All right, I have successfully set up my box where I put the first linear factor on the side. I put the leading term of my polynomial inside. Now I can begin the process. The process has us looking at the outside values, x times a mystery value to give us the inside box here, 3x to the third power. Let me double check mentally. X times 3x squared, is it 3x cubed? Yes, it is. Okay, now we're going to multiply negative 1 times 3x squared, and that should give us negative 3x squared. All right, looking good. Now I'm going to go ahead and see if I can figure out 3x squared plus something here. Not sure what that is. Needs to give us this first right here. Negative 4x squared, this first, where I labeled number 1. I don't know what I'm trying to say there. So I'm going to go ahead and actually create a little equation here. Negative 3 plus something needs to give me negative 4. Okay. Negative 1. Okay. Negative 1x squared. Looking good. All right. I'm going to write it right here. Negative 3x squared minus 1x squared. That gives me negative 4x squared. Looking good. Okay. Now I'm going to go ahead and repeat the process, start over. X times a mystery value gives me negative 1x squared. That's going to be negative 1x. X times negative 1x, negative 1x squared. Yes, looking good. Okay, now I'm going to multiply these outside values. Negative 1 times negative 1x, and that's 1x. All right, let's keep going. Now I need to think to myself, I need two diagonal values that are going to give me the second annotated term here. Negative 9x. So 1 plus something, this is something, the mystery value, is going to give us negative 9. Okay, there it is, negative 10. So now 1x minus 10x gives me negative 9x. I'm writing it here to make sure that whenever I go back, I have something to refer to in case I made a mistake. I'm like, did I make a mistake? But nope, this looks good. Okay, start the process again. Outside values, x times the mystery value gives me negative 10x. That's negative 10. I'm going to multiply the outside values, negative 1 and negative 10, to get positive 10. Put a little box here to remind myself that this last part of the calculation needs to match the constant, the last term of my polynomial. If that happens, we are good. We are done there. I'm going to erase these extra boxes. I don't need them. I am also going to erase these calculations to make space for my second division. Now that we have conducted that first division, I'm going to put a check mark there. And I'm also going to put this result here. Yeah, I'm going to put it right here. 3x squared minus 1x minus 10. So this is what I just wrote right here. This item that I circled, I wrote it right here. So what I need to do now, the reason I do the second division, and I need to figure out what x minus 2 times that mystery linear factor, these two items need to multiply and give me that. So that's why I'm going to divide by x minus 2. So I'm going to divide this polynomial that I got right here, divided by x minus 2, and that will give me this one right here. All right, so let's go ahead and begin that division. All right, our second division is by x minus 2. We are going to annotate here. So that's 3x squared. And I'm going to put number 1 here. This is going to be the term that I need to add up at some point diagonally. Okay, let's begin the process. All right, x times an outside mystery value will multiply it to give me a product of 3x squared. That is 3x. Let me say it to myself. X times 3x is 3x squared. Yes, that's good. Now I'm going to multiply here. Negative 2 times 3x is negative 6x. And now I need to figure out what gives me negative 1. So this here. I didn't make enough space for myself. So negative 6x plus something gives me negative 1x. Negative 6 plus something gives me negative 1. All right, I'm going to go ahead and add 6 to both sides. All right, so it's 5. So it's 5x. Let me double check that. Negative 6x plus 5x is negative 1x. Yes, that's good. All right, let's begin the process again. X times another outside value will create a product of 5x. That is 5. Negative 2 times 5 is negative 10. Yay! That's what I was looking for. I'm good. I got it correct. Now to write our answer, remember we need to write our answer as a product of the three linear factors, x minus 1, x minus 2, and the third one is 3x plus 5. All right, there it is. Let's see what we do.